Sir, one doubt I have, sir.
Yeah.
In the declaration, so this whenever we declare a in int or float, so it will be stored in the RAM, right, sir?
Yes.
Like we can know the memory location also, like if is there
Yes,
any.
yes, we can get the memory address as well.
Okay.
Right. But we can, if you print the address, they will print the address. I will show some example to you.
Okay.
The
And
problem here is in C programming, the memory location that you define for a variable will change depends on where you store your variable. Let us say I declare a variable in my C program called int a. In my main function, I do that. I just set int a. So do you know where that a is stored in the RAM? We have different sections in the RAM like stack, heap, and then the rest of the RAM. Can you help me where that is stored?
yes, sir, that part I'm not clear of. Like I have heard like stack, it may be stored in stack, but I'm not confident about it. So can you
Okay.
explain like
Then,
the.
let us understand practically by doing an example
Okay.
so that you will understand very clearly. Right. So let me create a program for that. Give me a sec. So let us do that. Notepad plus plus declaration dot C. So as usual, as include stdio.h int main of. So I have int a, b, comma c, right? Then I just initialize them, the 0, 1, and 2, right? Then I print their address where they are stored right now. So for that, printf address of a percentage x. I believe it is a long XL, I believe, if I'm not wrong. Long X or XL. Percentage X, comma, address of A. I'm asking to, I'm asking the program to print not the value, but the address. Printf value of A is equal to percentage %d, comma, A. Right now. I do the same for other two variables as well. So the first statement, when you prefix ampersand with a named memory location, you are actually asking the program to print address in which what address that particular named memory location represent. Because every variable that you have here is a memory location in RAM. Right. In RAM, we have different sections, stack, heap, and rest of the RAM. when we do a declaration like this, they will declare these variables in a memory section called stack. How? Because actually I'm just said int only, no, int a. Indirectly, that is, it is hidden actually, R2. It is a storage class. It is a storage class. By default, in C programming language, default storage class, if you don't use any storage class in front of a data type, they will store it in a stack. That is clear, no, for both of you? Stack is a part of your RAM. It is not an entire RAM, part of your RAM. It used to have numbered memory location. That means limited memory location, maybe some 100 stack pointer. That means they use that memory again and again. It is just like a temporary area where if you want to store there you can store things there for a small period of time and then you get it back. It is not like you will always store something there till your program completes, right? So for that only we go for the stack memory. If we don't define any storage class in front of our data type, they will consider that as an auto. Auto means they will store that in stack. Brilliant. Okay, in stack, they have a defined memory. Every microcontroller and microprocessor, they will say, we are using these memory locations of the RAM for stack. Stack as a property. What property it is? So when you want to store there, you have to push them. Push the data, right? See, if I have a memory location from, let us say, 10 memory location I have, 9, 8, 7, like that it will go up to 0, right now. When I push a data to this one, they will push that value to memory location. The very first time they will push it to the memory location 10. So A is initially stored in 10. The moment I declare B, what will happen is the content of this A, the value of A will be transferred to 9. And now on the top of the stack, we have B. Value of B will be stored. The moment they see the declaration of C, now the address of Z, previously address of A is, initially address of A is 10. After the B declaration, it becomes 9. After the third declaration, address of A become 8 now. Do you understand what I am trying to say? So on the top of the stack, you used to have very latest value that you pushed.
Okay, so C will be at the top of
Top
the
of
stack.
the stack.
Okay,
This is how this memory location is, right? They have stored it. So now I am asking them to print. Let us see what happens. Actually, when we declare a variable, they store that in some memory locations in stack. The stack follows this property, last in, first out. Right now, that concept.
yes, sir.
Right. So if you may ask me a question, after they reach the end of the stack, they are pushing like this. After that, there will be a stack overflow. That we will discuss about later, how they handle it.
Yes, sir.
Got it now. So now let us run this program and see what we are getting. You understand, right, the concept of stack and why by default the variables in main are stored in stack? Clear?
Yes, I'm sorry.
Okay, brilliant. So let me run this program now. GCC decl.c hyphen o decl.exe. Okay, I think I put 0 instead of o. Okay, so in the last demonstration, I used just gcc file name dot c. That is what I did right now. Preprocessor dot c I gave. The output file that we got is a.exe. Now, if I press A, I will get that old program only. What is the change that I did now? Now I told what may be my output file name. So don't use default file name. Use this file name that I specify. So now I specified my file name as decl.exe. So that will run. So they will store it in that one. Right. So I can type now decl. So it is printing, right? Actually, I don't have a new line in between, but anyhow, it's okay. Address of A 61FF1C. Value of A 0. Address of B 61FF18. Why 18? See, 1C, after 1C, it should be 1D only, no? Yes or no?
Eight.
It's next memory location only, right? Next memory location only, right? Why they are using like that? Go on.
As you mentioned, stack pointer goes down.
See, this is lowest value. This is 1C is the higher than 18. Yes, 1C, 18 is higher than 1C. 14 is higher than 18. So who is at the top now? 14.
Sir, 1.4 is lower, right?
Sorry. One sec. I think address of C 61FF14, value of C equal to 2. There is some truncation, I believe. It is not a full value that we are getting. Maybe I make some mistakes in the format identifier. Let me fix it. So I have to say percentage unsigned X. Just if I say like that. I think it is a problem with format identifier. Let me fix that. Still same. Unsigned long. Night 1418 1C. So if you look at this, this is the C is the very bottom, right? No, 14 and then 18 and then 1C. To print the address, we use hex.
Yes, sir. Like 1.4, 32 bits they are showing, sir. 32 bits.
That is true. 32-bit integer. So if it is as they have an offset of 4 from 4 to 8, right? We have 4 byte. For each integer, they require 4 byte. My question is, actually, this C should have the higher address than A because that is at the top, right? But here, maybe they use they store it from the lower address. A is stored at the 1C and then 1 8. Maybe they, in order to pick very easily, they have in this way. Instead of storing at the top, they store it from the from that address, but it becomes a queue. No, then see, this is the as per the explanation that we had. We have a 10 memory location, means as of now what they do is they have an address 0x.
Sir, can you write like in the consecutive lines? Then
Yes, we will do that. Yes, I will do it. So what we can do, /n. Right. So 2921 and then 92 96 from here 4 byte, right? From here 4 byte is 300. That makes sense right now. Initially, let me make it to in X so that it is very easy for us to see that. Then we can even put a 0x in front of them. This is perfect. So we have a X number, right? So 92, 96, 300. Why we have a 4 byte gap in between each entity? That is because the computer, this particular compiler, GCC compiler, handles alert 32 bytes to store a single number, single integer, right? If I change the same thing to a character data type instead of integer, if I change that one to character, what will happen now? There will be a consecutive memory locations, because within a one character, 1 byte, we can store these numbers right now. Three not 1, 302, 303. Got it? So the number that you store always, maybe I think they start from this memory location. From there, they simply push them, copy them to the next memory location. Right. From 301, initially we have A. Let us do like this. Let us do this experiment. They are storing in stack only. No, now we can understand. By commenting these two things, we have only A now. Correct now? Right. So I store that and then I run that compile that program. Okay. %C, address of C we are asking to print. Then right? Here, what is the problem that they are saying? Undeclared. Okay, maybe I think we didn't declare them because we commented them. So let me comment those lines from here up to here because we have only a variable a now, right? So let me save that and run it. Right? So 303. Address of A previously it was 303, even it is 303. So previously allotted memory for 303 is the very lowest location. Okay, brilliant, perfect. So they didn't assign 301. When we have only A, so they store that in 303. Moment we get B, they store that into 302. Moment we get the C variable, they store it in 301. Now I am going to change the pattern. See how they are aligning in stack. Maybe they handle the stack in a different way. So let me have an additional variable. See, at present, the memory location at which we store when we have a 3 variable, one sec. Right now. So, sorry, actually it store it in the memory location 303 when we have only A. Now additionally, I have a variable D. Let us see what happens. I actually have a D variable, no? Yes. So now okay, maybe I didn't print their address. See, we print that D. Right. So we compile it, we run it. So where is D? Here we make mistake. So depends on number of variables that I have. They go that much deep to store. They go that much deep to store the variables, right? So initially we had A, so that is in 303. Then we come with B, they store it in the 302. C, which is going in 303, like that they store. But this is very strange, right? So if that is the case, the top of the top of the stack is 303, right now. They go in downwards only, no? If I add additional one more thing, they will go to 299, right now. Agree? Agree or not? See, if I add an additional variable, they will go and store it in 6422 299.
Yes, sir.
Yes,
Yes, sir.
if that is the case, the concept of last in, first out is not true here, right? Whatever that we get, okay. From the last, very last variable is D. So that we are getting first, correct only. True. So after we save that here, but why it is printing C instead of D? We have to get D only, no? I compile that. Right. So now, as per the pointer wise, when we point 300, it will point up to 303. It will go up to 303. Right. The top of the queue, the top of the stack, the very least address in this stack address is, that is the top right now. 300 is the top. In the top of the address, what we have D. Moment we take the D out, when we remove the D, C will come to the top. That means C will be the value of C that we have, the 2, no, that will come to the top. Like that it used to work. So from this, address wise, the first address is given to the last variable that we declared. Correct? Correct? Yes or no? This is the last variable in this list.
Yes, sir.
For that, the very first address is given. While we run the one, while we read it from that, the very first address, when we take it, what data will that we will get? The data that we pushed very last. Yes or no? After that only we have C, we have A, something like that. So let me do that in a different way. I'm going to, instead of reading them individually, I can do like this. Int PTR. That means a pointer. I think I will explain what is pointer later point of time. Pointer equivalent to the is equal to address of C. Why I pointer equivalent to address of B? Because I know that that is what the very top of the stack. Right. From there, I want to read data. So what I can do is, totally I have 4 variables only, no? For that, let me have an index variable here. Otherwise, you can do like this also. For in index equal to 0, then for index equal to 0, index less than 4, index plus plus. Right. So here I print the value right now, percentage D, value pointed by pointer, star PTR. Right. After that, I simply increment the pointer. PTR plus plus. Yeah. Let us see what happens now.
You haven't given semicolon, I'm sorry. In for loop.
Okay.
And above that line, 17
Above that
PTR
line,
D.
PTR equivalent to D. Sorry, I made mistake here as well. So now we will get the value right now. So it is moving forward and it is decreasing. Okay. As we are working with Python and other stuff. PTR equivalent to address of D. Assignment from incountable pointer type. Okay, because it is a integer pointer, because these data are character, so we have to declare a character pointer. So what I can do, I can convert this to this also to cap. Now right. So the lowest address 98, 97, 96. 98 we have 0, which is the very first one, right? D address is 5, but in that address, why we have this value? Maybe I am using value of D is equivalent to D, correct only, no? Pointer plus plus 0, 1, 2, 3. So here 1, 2, 3, 4. But fourth alone we are not getting appropriate value. What value that we gave for D? It is 3. So 33210. 3210. Maybe
Sir, you for a pointer you are given D, sir, right, sir?
see, I
Address of D.
initialized address of pointer is given here, right? Now the address of that, whatever the address in which they store D, that we are given to pointer, right? And then we increment the pointer.
Answer, you didn't give say line separation. That's why they are printing in single line. 3, 3. From 16th line, you made the for loop with printf straight away without new line character.
Thank you. Correct. So actually they are printing it as we 3210. That is correct. From the decrement they are printing. This 3 is why that happens. I think there is a reason for that. I will tell that. So then we compile it. We run it. Value of D 3. Okay, as we have okay here also this is with this value it is going and attaching. That is the problem. So when we do that in a new line, so that will be perfect. That this 3 is we are getting it from this printing. Right now. So this is we are printing and it is printing the value in a decrement order. So when we give the address of D, from there we simply move forward. When we move forward, we get the very first value that we stored in that at the last. So from this, what we conclude, though the variable that we declared without any storage class is using auto as a storage type. Storage class. Auto storage class means they store the values in stack memory. As they store the value in the stack memory, so first value that you give to the stack that you will receive very last. So that happens here. So the first value that we have declared here is A, but we are not getting it first. We are getting it very last. So now you understood, right, how things works? Come on.
Yes, answer.
Yes, sir.
But
Yes, sir. Stack, like it works like from the bottom to top, right, sir?
Yes.
That's why I think we are getting a.
Yeah, where it is going to the bottom. From there, they keep on storing the value. The very last value will be at the top of the queue. So that's why we get the address for the D. The address of D is the very least value. From there, it goes to the top. That means it goes to the next level, right? So 6, 7, 8, like that it goes. So the other every time when we push something that goes to the deep one level deep, and what you get is at the top of the stack is what you stored very last. So that you are getting. While receiving, while we are printing, it prints in that way. 3 first, 2 second, 0 1 third, 0 fourth, like that. If you have an additional declaration, that will come first. So if I make another declaration here like E as 4, I will get that. Maybe I can do, I have to increase this value because now it is 5. What is this? 3 to 4 has come very.
in 17th line,
Okay, the reason is, I know the reason. We have to give that address as E. That is the mistake that we did. Right? 43210. So it always store very last value that you have when you that you stored will be received first. So that is how the stack works. By default, the declaration that you make in C program uses the stacks to store variable. From this, we come to know that these variables are stored in stack. Right now, clear?
answer. I had a doubt. Answer.
Yes.
Usually in C programming, we used to mention that local variables will not be stored sequentially. Only the arrays will be stored with the sequential memory address.
Okay, perfect.
Here
The
you are
reason behind,
directly
okay, the
accessing.
reason behind that is they are stored in stack. That's why they follow this because they have to reserve some memory from the stack. Right. So if I, for example, in between all these things were characters. Let us say I declared these two character. I asked these two variables are character, and then I store this variable as integer. C and D are integer. Do you think they are sequential now? Will you think they will have a sequential address? No. They will have an address. These are having 4-byte offset because this computer or this OS handles integer 4 bytes per variable. So your address will be something different. But still, these variables are stored in stack only. They will follow the same method. But I cannot use pointer to print them. So as it is having a mixture of data types, so I have to use a integer pointer to print them. And for these two, I have to use a character pointer. Right. When I try to use the same a character pointed to this address, I don't think I will get an exact value that I want. Let us check now. So we have this one. No, I have declared pointer as integer now. I change the pointer to integer now. So, and I point the address of pointer to E. Right. So let us do. See, 4, 3, 2 we are getting. 4, 3, 2. These are integers. So as we are using pointer, every time when I use plus plus, it will move in the step of 4. Right. But after this 3 variables, what I have is A and B. They are of character data type. For that, what I get? I get something else. Right now. So I get some junk value. That is the reason behind that is very simple, because we are not using appropriate pointer. So the address that they allot in the stack will differ based on the data type of the variable that you declare. But all of them are stored in the stack. Okay, when they store in a stack is also an array only, array of limited memory locations. Right. So you within the stack, which address they will give to the variable, that is what unsure. But obviously, when they are stored, maybe the people doesn't know about the complete architecture of how computer works, how C works. In that sense, they can say we do not know. The local variables will not have which memory address they allot, but where they allot. If we ask that question to them, where they allot, that will be there is an ambiguous area, right? So the clear explanation is the local variable that we declare are stored in the memory called stack. If we declare them without any storage class, default storage class is auto. Auto uses the stacks to store variables. The stack is again an array of limited number of memory locations. In that, they store it in a way that the last value that you store, that you can get it first. So in that manner they store. If that is the case, the addresses will be sequential only if you use all variables in same data type. Right, they will have equal offset if they are integer. If as they are character, to store a character 1 byte is enough. That's why we have a next immediate address. Right. So where they pick these address, they pick the address from stack. That's all. So from that, you can re-understand, or otherwise you can relearn what they told is. Yes, it is true. We do not know which memory location is given to this particular variable, and whether it is sequential or not. Sequential means if I know the address of A, it is easy for me to get the address of B by simply adding 1. But when it comes to integer variable, they do it in a different way. What they do? They reserve 4 bytes per variable. So here they make a difference. Right now, you cannot store D at the next memory location. You have to create an offset of 4 and then how to store D. But all these variables stored in the stack. Stack is nothing but an array. In that, we pick the memory location to store them. As it is done by the computer, it will immediately look for the address which is available very immediately. So it will take it and will use it. That's all.
Sir, understood. So by default, this pointer will take only one this one, right? So location one plus one location, memory location.
If it is a character pointer, when you declare, because the pointers are of different types.
Okay.
when you point a pointer with the character variable, while you are declaring itself, if you say my pointer is a character pointer, after that in your program, if you say pointer plus plus, it will go to next memory location only, because size of character is 1 byte. Okay, the same pointer, if you declare that as an integer pointer, and your OS and compiler support 32-bit integer, it will do in 4-byte offset for every plus plus. If it is a long and your compiler and OS consumes 8 bytes per long variable, the long pointer will jump 8 byte when you make pointer plus plus. I hope I answered your question.
Yes, sir. Understood.
Right now. Clear?
Clear, sir.
What I
Yes,
mean?
sir.
Shall we proceed to the next?
Yes.
So
Yes,
this is how they allot the memory for variables and use it. Now we have experimented that whether what we are discussing is correct or not.